Good morning, all. This is again Priya Gajjal. Now, the topic is safety terminologies, standards, and regulations. In this chapter, we will cover what is the workplace hazards, risk, and control measures. One by one, we will see what are the types, their hierarchy, indicators, and flammability. Now, first is what is hazard? Common name we all know. Technically, we have to go through. So, that is a hazard is any source or situation with potential to cause harm. Hazards exist in all workplaces. First step in risk management is identifying hazards. Now, example slippery floors, flammable liquids which may cause harm. Now there are different types of hazard. We will see one by one. First one is physical. Physical includes environmental factors that harm the body. Examples noise, by heat or maybe with the radiation. The second part is chemical. Exposure to harmful chemicals like acid, solvents, etc. Next comes biological, that is harm from living organisms such as bacteria, viruses. The next one is ergonomic, which explains poor workplace design causing strain, that is repetitive motion, heavy lifting, etc. Now, psychosocial, stressful work environment, maybe it for long hours and harassment. Mechanical hazards are hazards from machinery, which may be sharp edges, moving parts, etc. Last one is environmental, which comes in a natural condition or disaster, floods or earthquakes. Now, categorizing hazards helps in applying specific control measures. Hazards may overlap, but we can use specific control measures for the same. This is the detailed description. What are the different types of hazards? What is a description and what is a example? Same we have seen in a point form. Now this is in a table form. It will be easy to remember all this thing. So we can go through all these description examples and different types. Now the important factor is what is risk. The risk explains that likelihood and severity. Likelihood means it may happen, but what is the severity? So example is, for example, if there is a flammable liquid, then what is the severity? It may be medium likelihood and high risk severity, which is a significant risk. So that's why risk is always defined as likelihood is multiplied by severity. Now risk is assessment helps prioritizing the hazards. We can able to find out which hazard we have to tackle first and which may be tackled later on. So this gives you the risk assessment. Now use risk matrix. There may be low, medium, high. In some cases it will show by the color code. The low will be some different color, medium and high will be with some different color to categorize what is the severity of the risk. Now, hierarchy of hazard control is first one is elimination. Elimination is to remove the hazard completely. Means there is no option, you have to just remove it completely. Then it comes next the substitution. We can replace with safer alternative. Now engineering controls are isolate people from hazard. Administrative controls are change work methods. And PP is your personal protection as last line. So now from these five things, the most effective one is elimination and substitution. And the least effective one is relying on any PPE kit. So control measures, we can have different types of control measures. First is preventive one, which avoid exposure. For example, guardrails, proper storage. So we can avoid exposure by using all this thing. Now mitigative is reduce severity. For example, we can use fire extinguisher in the industries where there may be chances of fire and all that catch fire, so we can use a fire extinguisher. So this is the difference between preventive and mitigative. In preventive, we are trying to avoid exposure by guardrails or proper storage, and here we are taking a precaution. If suppose a fire, if anything catches fire, so we can use by fire extinguisher. Now continuously you have to monitor and take the feedback for with the help of inspection, audits, incidents reporting. Here control measures must be practical, measurable and monitored. Now, lead and lag indicators. Now, what is lead indicator is we are predicting and preventing the incidents, and the lag one is measure performance after the event. So you can see in the table here. So what is the indicator? Here is a lead and lag. Type is proactive because we have to predict and prevent the incidents, and here it is a reactive. Examples in lead one is safety training, inspections, PPE kits, compliance. Now in lag one, there may be the accidents, lost time incidents, near misses. So here after the event happens, we can take a precautions again. But in lead one, we have to take a predict and first preventive measure. Now there are flammability. This deal mainly with the chemical industries or where maximum chemicals are used. Just an example here it is gone through. Now definition is ability of a material to ignite easily, that is called as a flammability. Now we are having the classifications for this one. So highly flammable is here greater than 23-degree flash point, flammable is between 23 to 60 and combustible is less than 60 degree centigrade. Now the control measures for this flammability is flame proof storage so that it should not catch any fire, keep away from ignition sources, proper labeling and PP, which is very important, fire extinguishing and suppression system which can suppress the fire or anything happen or whatever the acids are there, fumes are there, so it will suppress that particular parameter. Now here you have to remember that flammability is a high risk hazard in many workplaces, specifically if you go through chemical industries or any sort of industries, and safe handling is really difficult over there, that's why it is critical. Now just we'll go a short summary up till now what we have gone through. Hazards we have studied, what are the different types of hazards, and the meaning is simple way that potential sources to harm. Then we are having physical, chemical, biological, ergonomic, psychosocial, mechanical and environmental hazard. Risk is likelihood into severity. Here it is written so that it will be easy to remember. Now how to control hierarchy, that first eliminate, substitute, engineer control, administrative control and PPE. So from here eliminate and substitute is first important. PPE is the least one. So that's why we have to first concentrate on eliminate and substitute. Now different indicators we are having two main, lead and lag, which is called also proactive and reactive. Flammability is handle with care, that having a high control risk. Now next comes that is toxicity. The definition is toxicity is the ability of a substance to cause harmful effects in a living organism. It depends on particular dose, duration and route of exposure. Now substances can be acute toxicants, it may cause harm quickly, or chronic toxicant cause harm over a long term exposure. Just a few examples for acute one, inhalation of high concentration of hydrogen sulfide can cause immediate death. If you go through chronic toxicant, there will be long term exposure. For example, to benzene can cause blood disorders like leukemia. So these are the acute and chronic toxicants. Just example, if you go through key parameter has been explained, that is LD50, that is lethal dose 50%, dose that kills 50% of a test population. And the next one is lethal concentration 50%, concentration that kills 50% of test population. So these are just tried to explain with the examples. Now then comes your time weighted average, which is the short form, or you can say the call denoted by TWA. So what is now TWA? It is the average concentration of a chemical substance in the air over a normal work shift. Usually the work shift will be 8 hours per day or 40 hours per week, to which a worker can be exposed without as adverse health effect. So normally the time will be 8 hours per day. We are just taking average time. So here it goes the average concentration of chemical substance. Just try to explain with the formula, that is TWA is C1 C2 C1 into T1 plus C2 into T2, like that, and divided by the average total count of that one. Here C1 C2 means concentrations during different periods, and T1 T2 is durations of exposure. So with this small example is given. For example, the worker exposed to 50 ppm of a chemical for 4 hours and 100 ppm for 4 hours. So it means this is a C1 and this is your T1. So here C1 multiplied by T1 plus again this is C2 and T2. So here this is C2 and this is your T2. So divided by 8, that is 4 plus 4, 8 hours. So it comes to 75 ppm. The total weightage time is your 75 ppm. Now TWA used for chronic exposure evaluation. If exposure exceeds TWA, health risk increases over the time. For example, in the atmosphere, if it is more than 75 ppm, then health risk increases over the time. So this you have to take care. Now the next part is threshold limit value, which is also called as a TLV. Now I'll see the definition of this one. TLV is recommended maximum concentration of a chemical in the workplace air that most workers can be exposed to day after day without adverse effect. So there may be chances of this one. Now what are the different types of TLVs? The first one is TLV TWA. Here this is average concentration over 8 hours per day or 40 hours per week, which matches TWA concept. Just we have gone through what is a TWA. Now TLV, that is short term STEL, that is short term exposure limit. We will see this in the next slide. Now TLV C, that is the ceiling value, maximum concentration that should never be exceeded. So this is a limit. If it is there, it should never be exceeded. Short term exposure limit, we are having this for a short term. TLVs are only the guidelines, not a strict legal limits provided by ACGIH, that is American Conference of Governmental Industrial Hygienists. Helps in designing ventilation and PP requirements. Now just example, TLV, that is a TWA of acetone is 500 ppm. That means worker exposure should not exceed 500, an average of 8 hours per day, or we can say 40 hours per week. But it is better to go for calculation of per day so that we can exactly get is what is a ppm count. Now as I told in the last slide that we will deal this within next slide. So this is here short term exposure limit, that is STEL. Now STEL is a maximum concentration of a chemical that workers can expose to a short period, that is hardly usually you can say 15 minutes, without suffering irritation, chronic or irreversible tissue damage or narcosis. Usually expressed in ppm, meant for peak exposures in addition to TWA. It should not be exceeded even if the 8-hour TWA is within the limits. So here this is exposure is only for 15 minutes. Just an example, TLV STL, that is short term exposure limit of acetone is 750 ppm for only 15 minutes. So worker can safely be exposed to 750 ppm for 15 minutes only, provided TWA over 8 hours is be less than 500 ppm. So always whenever we will calculate TLV STEL, we have to go through what is the TWA value. So this is the just a diagram here. So from 0 to 8 hours it is there. So it is started from time weighted average. Upper will be shown as a TLV, that is a threshold limit value, and here this is for a short term period, that's why STL short term exposure limit. This will be hardly for 15 minutes. It will be mentioned in the theoretical part or practical part and in the charts also. Now up till now what we have gone through, I've just listed in the table here, that is what is toxicity, what is TWA, what is TLV and what is STL. This is easy to remember if we put in this direction. Now it's an important one, that is IDLH, that is immediately dangerous to life or health. So what is IDLH? This is the maximum concentration of a hazardous substance that poses an immediate threat to life, causes irreversible health effects or hinders escape. This is said by NIOSH, that is National Institute of Occupational Safety and Health, for emergency responses and safety planning. Requires immediate protective measure. That's why it is immediately dangerous to life or a health. Now what are the different characteristics of IDLH environments? Here high concentration of toxic or oxygen deficient atmosphere, rapid onset of adverse effect, emergency response required, only trained personnel with SCBA, that is self-contained breathing apparatus, should enter, because they are having a practice on this one. So that's why this apparatus only training persons can be used and they can go through the entire process. Now here also we were going to study what is the acute effects and what is the chronic effect. Now acute effects are occur soon after exposure. It may minutes to hours. The examples: you may feel dizziness, nausea, headache, eye or skin irritation, respiratory distress, unconsciousness, or in a extreme way, death in a severe cases. Usually reversible if treated promptly. So these can be treated if it will be in a preventive way, or suddenly if we can treat promptly way. Now chronic effects results from repeated or prolonged exposure over weeks, months or year. Develop slowly, often unnoticed initially. So these are the examples of lung diseases, neurological disorders, organ damage, example liver, kidney, cancer or reproductive effects. This may be irreversible. Acute may be reversible, but this type is irreversible. Now, what is the route of chemical entry in a human body, or we can say in the area where everything is there? The first one is inhalation. The most common in workplaces are gases and vapors and dust. Then dermal absorption, that is through skin contact. Ingestion, that is contaminated hands, food or water. The injection through punctures or accidents with sharp tools. So these are the different routes where chemical can enter in the body. For this one, the next one is your personal protective equipment, which is also called as a PPE kit. Here, for respiratory protection, you can use self-contained breathing apparatus, which is SCBA. For IDLH situation, air purifying respirators, that is a non IDLH only. Skin protection, we can use chemical resistant gloves, suits, aprons, boots, etc. Eye and face protection, you can use goggles, face shields, etc. Now, hearing and head protection, we can use helmets, earplugs, muff if it is applicable. Now, safety measures in IDLH environments are risk assessment before entry. I already told you risk is a likelihood into severity. So you can get a table and you can find out what is a risk assessment. Use of SCBA and protective suits, buddy system and trained rescue teams, emergency response plan in place, and continuous air monitoring. Now here also we have gone through the routes of chemical entry, PP, health and safety policy, and MSDS. I'll repeat MSDS in the next slide here. Now same thing, understanding how chemicals enter the body and how to protect workers in essential for occupational safety. Once we know what are the different routes of chemical entry, then we can take care, we can take some preventive actions, preventive measures. Now we are having a different policies, equipment and information sheets. So if we work together to ensure safe working condition, we can reverse back many odd situations. So again here the same, it has been explained, that is a different types of inhalation, dermal absorption, ingestion, injections, so that awareness will be proper way. Acute effects, chronic effects, then severity depend on chemical concentration, duration of exposure and route entry. Now PPE is also, what is the purpose? To protect workers from hazards that cannot be fully eliminated by engineering or administrative controls. Type of PP, we have already seen this one. Respiratory protection mask, SCBA for hazardous air, for skin protections, eye and face and head hearing protections. Now we are having a different health and safety policies. It is a written commitment by an organization to maintain a safe and healthy workplace in the industry or wherever manufacturing units or workplace is there. Now what is the key element here? Employer and employee responsibilities. The responsibility is from both. This is the employer also and employee also. Identification of hazards and risk control measures, emergency response procedures, training and communication, regular reviews and updates. If we continuously go through all this process, we can avoid the odd situations in workplace. It reflects the organization's safety, culture, and legal accountability. What is MSDS? That is a material safety data sheet. So each document containing detailed information about chemicals used in the workplace. Which helps workers and emergency personnel to understand the hazards and safe handling methods. Now there are different sections of MSDS. Just I'll go through this one, that is identification of substance and supplier, hazard identification. If we able to identify, things can be reversed, composition or information on ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure controls. We can use PP kit for that one. There will be physical properties, stability, toxicity, regulatory information, etc. So these are the different sections of MSDS. What is the importance of MSDS? This provides critical safety information to workers, guides PPE selection and safe handling, supports emergency planning and medical response. Here, legal requirement under many regulations. For example, the factories at OSHA. OSHA is Occupation Safety and Health Administration. This is a US federal agency under the Department of Labor. So maximum, the reputed industries, reputed chemical factories and all that, they are using this OSHA regulation, so that whatever the emergencies will be there, whatever the accidents will be there, that can be avoided. Now, just in a fast way, we'll go for the summary what we have gone through until now. So, chemicals can enter through inhalation, skin, ingestion, and injection. We have to take care that one to avoid all these things. We are having a different PPEs is the last lines of defense, but it is a critical also. Health and safety policies set the framework for workplace safety. You have to display all the health and safety policies first. Later on, you have to discuss with the workers or the people who are working in the workplace, so that safety can be maintained. They should be get a knowledge which type of ingredient or which type of chemicals they are using, what is the level of ppm, what is a safe level of ppm. If they understood all these things, so we can avoid really critical situations, because MSDS provides detailed hazard information and safe handling instructions. So all these references are from different thing. Thank you all.